All right, we're looking at is taking our radicals, the square roots, and trying to figure out when we can add and subtract those. So the important thing is we're trying to treat each of these as if this was 3x minus 2x, so we would get 1x. So if I have 3 square root 5x and 2 square root 5x, these are the same, so we can do that. So that means I will get, in this case, 1 square root 5x, or just the square root of 5x. So the idea of like terms is really going to grow as we take a look at some of these. So for multiple reasons, square root of 7, square root of 5 are not the same. So this one is simplified. There's nothing else we can do with it. So here we have a problem with the index being 3 and the index being 5. So again, this is simplified. Nothing else we can do with it. Where are we going to use it? We can use it in some applications. Anytime we turn a square root into a decimal, unless it turns out to be perfect, then we're causing a rounding issue that eventually makes it wrong. And each time we use it, it becomes more wrong than the last time. So if we want to find the perimeter of this window, we know that each of these squares in here is going to be a 5-inch by 5-inch. So the first thing is, what's the diameter? Well, a squared plus b squared equals c squared. So 5 squared plus 5 squared equals the hypotenuse squared. So that's 25 plus 25 equals c squared. So 50 equals c squared. Now we're going to take the square root of that. So here's what we have is the square root of c squared. So what's the square root of 50? Well, that's 25 and 2, so it's 5 root 2. Well, that's not my answer because that's not the perimeter. So what we're going to do now is go around and count up all these sides that we have. So I have 1, 2 of those on the bottom and 2 on the top. On the sides, we have 1, 2, 3, 4, 5, 6. So I think the best way to do this is to realize that I need 10 of these. So we're going to multiply by 10. So we're going to be up to 50 square root 2. If you truly want to use the equation, this is where it gets a little bit complicated. So I have 2 times the width, which is 2 times 5 root 2, plus I have 3 on the side, 3 times 2 root 5. So 3 times 5 root 2. But at the same point, I need 2 of these. So you can see how we're going to get 4 here. Squeeze another 2 in here. All right, so we're going to get our 10, 20 root 2's here. And here we're going to get 10 and 30 root 2's here. So we're up to 50 root 2. So it's using our perimeter 2 times the length plus 2 times the width. Okay, so if we ever have a picture, you can see how it's a lot easier to just count out how many of those we have. But we get the same thing either way. So quick review of what we have. What's the simplified version of each one? We have root 3, or cube root of 3, or cube root of 5, and a square root. So this one is simplified. There's nothing else we can do with it. In the second one, we do have a match, so we're ready to move on with that. So if you have 3x plus 4x, that's 7x, and you're going to keep the xy on top of that. And the next one, make sure everything matches. 5 is the index, 3x squared. 5 is the index, 3x squared. They do match, so 17 minus 15 is 2, and then we'll write everything else. So 5th root of 3x squared. So all in all, it's just like terms, but we have a lot of stuff going on to make sure they match. And then, oh my, we're going to give you some things that you would say, oh, I can't do that. It's simplified. Well, it's not simplified because these individual terms are not completely simplified. So 12 is 4 and 3. So it actually becomes 2 square root 3. 75, you are 25 and 3. So it's a pair of 5. So it's plus 5 square root 3. And then it's minus the square root of 3. Remember, that's 1 square root 3. So 2 plus 5 gives me 7, minus 1 is 6. So 6 square root 3 becomes the answer. Now this one was nice because it did give me a square root of 3 on the end. So that's what I'm trying to make the other ones match as I simplify it. So what I can do each time is just divide it by 3 and see what the other term is. That's a very good strategy. So simplifying each of those. Next thing I do is I can ask you to multiply. So here we're going to FOIL. So we're going to take 4 times 5 is 20. We're going to work on the outside. Outside things multiply with outside things. So 4 times 4 is 16. And then I have a root 2. On the inside, 2 times 5 is 10. And there's a root 2. And on the very end, my last term, outside things multiply with outside things. So it's 8. Inside things multiply with inside things. So square root 4. Do you know the square root of 4? Absolutely. That's a plain old 2. So that means I have 20. We got like terms in the middle. So plus 26 root 2 plus 8 times 2 is 16. So I have like terms one more time. 36 plus 26 square root 2. So we're combining that multiplication from the beginning of the chapter with the addition now when we start to FOIL. All right, let's try that again. So first term is 6. On the outside, 3 times 4 is 12. And there is the square root of 5. On the inside, 2 times 2 is 4. And there is the square root of 5. And on the very last, 2 times 4 is 8. 5 times 5 is 25. Now we know the square root of 25 is 5, so we're going to cross that out. I have like terms in the middle, so 6 plus 16 root 2 plus 8 times 5 is 40. Like terms on the bookends here, 46 plus 16 root 2 becomes my final answer. All right, we're not going to get into rationalizing the denominator, so we'll cut that out. All right, so real quick, do we understand? Can we put these together? So if I have root 11 and root 10, nope. This is simplified. And the next one, can I put 2 square root 3xy and 7 3xy? Yes? Okay, so what would my answer be? 2 and 3, or 2 and 7 makes 9 square root 3xy. And then the last one, can I put 13xy with 6xy under the radical? No. All right, so some things we want to take a look at is top section. This one goes along with your stained glass. We can definitely multiply these. Remember, if there's anything on the outside, as we make this into 9 and 2, and it becomes 3 and 3. So we get a pair of 3s, so it now becomes 18 square root 2. 50 is 25 and 2. We just dealt with that one. So 5 times 5 times 3 is 15 root 2. And now we can add those together to get 33 root 2. So with that extra number on the outside, that's how we deal with it. All right, and again, we're not going to deal with the bottom section here. So I'll send those out as PDFs as needed. And you would check as you go. Make sure we have all the answers and everything that we're trying to do.